Lesson 2.8, Imaginary Numbers, the meaning of I. Okay, so basically until now, everything we work with have been real numbers, which are rational, irrational, and anything you can place on the number line. Since we've been talking about radicals, think to yourself, what is radical 25? Well, the answer is 5, because the number times itself that equals 25 is 5. If you think to yourself, what is radical -1? In other words, what number times itself is -1? The answer is there is no number times itself that equals -1. And that's why the number I was created to define radical -1. It's imaginary. It's impossible, so we say it's an imaginary number. So this right here is the most important piece. I equals radical -1. So an imaginary number is a complex number whose squared value is a real number not greater than 0. There are pretty interesting patterns when you take I to certain powers. I to the first power, I to the second power, third power, fourth power. You will see that there is a pattern that develops after after the fourth power. So fifth, sixth, seventh, and eighth power, you'll see that the cycle continues. So let's investigate I to the first power, which by definition we know is I, and I is square root of -1. I squared is just I times I, and we know that I is square root of -1, and square root of -1 times square root of -1 really is square root of -1 times -1, which you know is just -1. So let's highlight these. I to the first power is I to the second power is -1, and I to the third power is I times I times I. We'll expand it out. We know that I times I from our previous example here evaluates to -1, right? I squared, I times I is just radical -1 times radical -1, which is just -1, times I, and -1 times I is -I. Let's highlight that one. Finally, I to the fourth power can be written as I squared times I squared. Luckily, we know that I squared is -1, so we can just kind of shortcut to -1 times -1, which we all know is +1. So ladies and gentlemen, this pattern, I, -1, I, 1, is repeated every cycle of 4 powers. So I to the 5th, 6th, 7th, and 8th powers have the same result as I to the 1st, 2nd, 3rd, and 4th powers. I, -1, I, 1. I to the 9th, 10th, 11th, and 12th, same result. Let's look at some examples here. Radical -16. Now, I know that I can break this down into 2 radicals, radical 16 and radical -1. The square root of 16, 16 is a perfect square, it's just 4, and the square root of -1 is I. So in simplest terms, and in terms of I, radical -16 is simply 4I. You do number 2. Radical -9 is radical 9 times radical -1, which simplifies to 3I. Number 3, radical -200. Now 200 can be broken down to radical 100. The negative part can be pulled out to radical negative I, and the 2 is left over, so we have radical 2 over here. And the reason why I put it in this order is because when you simplify each piece, the result is the order that you want it to be in. We have the coefficient of 10, we have the imaginary number I, and we have the leftover radical 2. So this square root of -200 evaluates to 10I radical 2. Similarly, radical -300 breaks down So radical 100 times radical negative 1 times radical 3, so the result is 10I radical 3. Number 5 and 6, here we're going to add, we're going to subtract. So the previous examples we were just simplifying, now we're going to add and subtract. We have radical negative 18 added to radical negative 72. Basically, we're going to combine like radicals after we simplify. So as you can see, radical negative 18 is radical 9, radical negative 1, and radical 2, because we know 2 times 9 is 18. The negative comes out here. We know that negative 72 can be factored down to 36 times 2 under the radical, and the negative 1 is here. So when we clean this up, we have 3I radical 2 plus 6I radical 2, and we all know that when you add or subtract radicals, you can only do so with like radicals. And we have 3I radical 2 plus 6I radical 2, so we're going to combine the coefficients. 3 plus 6 is 9. The final answer is 9I radical 2. Number 6, same deal except it's subtraction. So we have negative 18 breaks down to 9 times negative 1 times 2, all under the radical. This gives us 3I radical 2, and radical negative 8 is 4 times radical negative 1 times radical 2, which is 2I radical 2. And combining like radicals, 3 minus 2 is 1. So the answer is 1I radical 2. And the coefficient of 1 is invisible. We don't need it, so we erase it. Number 9. So here we have, well, let's jump to number 10 first because it's addition. So here we're basically just combining like terms. We can combine the 2 and the 4. We can combine the 3I and the 5I. Nothing special about this problem. We end up with 2 plus 4 is 6. And 3I plus 5I is 8I. This is called A plus BI form. This is known as a complex number because it's a mix of real numbers and imaginary numbers. Now let's go ahead and look at number 9. This is subtracting polynomials or subtracting complex numbers, which is easy. We know that it's keep, change, change. We'll keep the first polynomial, change the operation, and then change each of the signs in the second polynomial. So now we have 6 minus 2, and we have 7I minus 3I. 6 minus 2 is 4, and 7I minus 3I is 4I. Now we all remember from our radicals unit that if you have a radical in the numerator, a radical in the denominator, you can put the fraction under one radical symbol and simplify or reduce your fraction. So negative 20 over 5 is really negative 4, and since it's under the radical sign, we can go ahead and factor out I. Radical 4 and radical negative 1 is 2I. Similarly, we can do the same thing in number 12. We have radical negative 36 over negative radical 4. Be careful about that negative outside here. That seems to be tripping some people up. So when you break this down, we end up with negative 36 over 4, which reduces to negative 9. And now we have a negative out here. We have radical negative 9. We all know how to simplify a radical negative 9. It is 3I, and that negative coefficient is still out here, so the final answer is negative 3I. And finally, number 13 and 14. Now we know that radical negative 9 is 3I. We know radical negative 16 is 4I. Now since we're multiplying, 3I times 4I is 12I squared. Remember back to what I squared was. Let's go back to our table. Here it is. I squared is really negative 1. So we're going to use that information to put this over here. We have negative 12I squared is 12 times negative 1, which is simply negative 12. And over here we have radical negative 3 times radical negative 4. So we simplify this. We take out the radical negative 1, which is I radical 3. We really can't do anything with the 3, so it stays under the radical. And here we have radical 4 times radical negative 1, which is 2I. When we multiply these together, we're going to multiply the I times I to give us I squared. So we basically have 2I squared radical 3. And we know that I squared is really negative 1, so it's 2 times negative 1 times radical 3, which is negative 2 radical 3, which is our final answer. And there's the lesson for the day. Best of luck to you.